and hiring consultation and instrumentation will make this project possible. And thank you very much.
Thank you, Mr. Selvabalan. Now rapid assessment for the safety.
So Deltalis is a research institute in the Netherlands, and I will tell you something about rapid assessment tools for dam safety. So I would like to share some of the experience from the Netherlands. I thank the organization and the chairman for the opportunity to present our experience. So a brief overview of the presentation. I will talk about water management. I will talk about satellites, about satellite measurements. I will talk about Fuse Dam, our software system we use for safety assessment of dams and dikes. And finally, I will try to conclude in the time limit. Something about the Netherlands. The Netherlands is only a small country in Europe. I think already the state here, Karnataka state, already 5 times bigger than the Netherlands. It's important to notice that the Netherlands is a country which has a large part of the country is below sea level. As demonstrated here in this picture, you see our country. If we had no flood defense, about half of the country would be flooded. So we have had problems in the past with floodings. In the 1950s, we had a big flood in the Netherlands, in the southwest corner of the Netherlands, causing about 1,800 loss of life. And also later on, we had flood situations that made us needed for evacuation in the 1990s. So we had our share of problems. Also, looking at the internet, what's happening in India. For me, this is the first time in India and has been a wonderful experience. And looking at what's happening here, I noticed this one. Also in India, you see a lot of challenges with water management, drought, also flood. So to tell you a little bit about the flood defense system in the Netherlands, we have a lot of systems to make sure that we keep our feet dry, as we say. Here's the Netherlands, North Sea. These are our main rivers. So it's a threat from the sea and the rivers. We have dams, we have dikes along our rivers over here. We have moving barriers to seal off entrances to the sea, etc. So we have a whole set of things to work with. So now to the first innovation that we think is important to share also with you. That is an option to apply in India, and this is the use of PSESA satellites. These satellites are flying around the Earth. At the moment, new satellites have been launched in Europe, that pass also India twice a month approximately, doing measurements. And these measurements I'm talking about, they do local measurements. What I'm talking about here is persistent scattering radar. So you see here a picture, the satellite is flying over and sending out pulses and receiving reflections. Then on the second pass, about 2 weeks later, it will do the same, and we will look at phase differences between those reflections that you receive. And that gives you information of the subsurface, the surface of the Earth, and that is essentially the measurement principle of this system. So what does it bring you? It brings you a high precision of deformation of the surface of the Earth at millimeter precision. And also the images that you get are big images, about 30 to 50 kilometers, so you get information about a large area. You don't need any site access, you don't need any hardware, and you get high density measurements compared to alternative methods. So there are different satellites with different resolutions. The low resolution gives you reflections from 100 square meters, and the high resolution gives you at 10 square meters. I have two examples of this. Due to the time, I will skip this one. I will limit myself to one. This is a situation in California where you have an embankment dike. An embankment dike over here. This is Diamond Valley Lake, and here we have measurements with the satellite system. So you see here the results of such measurement, and on the left side here is the PS INSAR. On the right side are comparing measurements that are done by geodetic measurements. So you get a lot of information here. So you get your scatterers give a lot of information. What you see here is the deformation of this dam in millimeters per year. So you can see that there's a lot of deformation over here. But for example, here there's an area with much higher deformation, up to 5 millimeters per year. If you compare this with traditional geodetic measurements, you see a good resemblance that proves that the system works. And now this gives you a much more detailed information. And that's one of the main advantages of this technology. So that was one topic I wanted to discuss with you. The other one is our software and our approach to dam safety. So as geotechnical engineers, we are used to evaluate dams and dikes for their safety. In the Netherlands, we have a law that says that we have to do that every 6 years. And so this is a lot of work, because in the Netherlands we have a lot of dikes, about 20,000 kilometers, and so we started automation of this. And this software came out of that development. Not only do we do a lot more calculations, but also we use different types of modeling. So what we used to do is maybe every few kilometers make a cross-section to do your calculations, but nowadays we do a cross-section every 10 meters and do a calculation for different failure modes to assess dam safety. So we also work with stochastic structural models and different compositions of your dike, take that all into account of our calculation. And what you see here is such a length of a dike, and we estimate the subsoil conditions over here. And we're not working with one profile, but in this case we're working with two profiles with a different probability of occurrence. And the color and the layering of the soil is shown here, and the colors indicate the type of soil and the properties of the soil. And so we will do all the calculations and then show the result in a map and give the information to the owners and operators of this and the people responsible for maintenance of this dike system. And this information is very handy, because you can already see that there are areas like over here where not much is happening, everything is in the green, which means that for all the failure mechanisms the safety assessment is okay. But you can also see here, for example, over here, that a lot is in the red, which indicates that the dam doesn't meet the criteria, doesn't meet the standards. So an operator of the system immediately knows that he has to do more investigation in this corner to see what is really happening over there. So a next step is inverse modeling. So I will skip this one, but the next step is if you have a system where you have put all your information in databases and you are able to do a real-time estimation of dam safety, you also want to use the same system for forecasting. Forecasting involves the use of instrumentation. So in some of our dikes dams we have instrumentation, and this is sent over real time. And combined with the modeling, we are able to do forecasting of dam safety. And you see an example of this. Here you have one of our river dikes, and this is a situation with high peak discharge of our river. And here you see that we have put in instrumentation in the dams that are transmitting their information. That is combined with our modeling, and shown on this side is an example of the result of such such real forecasting is, where you see that in this area there are areas that are okay in the green and yellow, but there's also areas like over here that look threatened. So this is used for emergency action planning. So the authorities responsible for this are able to determine what to do. They can maybe reinforce the dike with an emergency reinforcement, or if necessary can do an evacuation of the population. And that's basically the system. So to conclude, I think I share a little bit that India and the Netherlands share a lot of challenges in flood risk management and water management and dealing with all these kinds of things. And I think we can both learn from each other, and that is an important aspect of our institute, Delta. I've shown you some examples on satellite monitoring, giving overview maps of dam deformation and historic dam deformation, and gives you the ability to determine areas with high deformation to focus on. I've shown you what we can do in safety assessment of dams, also showing this in overview maps, and which it's very easy to update and to design and evaluate measures. Thank you for your attention.
Thanks a lot. Presentations, one from Fresinet and one from Trimble. I would invite the Fresinet presentation first. I think we will have about 5 minutes to 6 minutes time, with which he can make his presentation, and then we will have a presentation from Trimble.
The opportunity to share the floor with you. So in few words, within 10 minutes, we'll try to sum up who we are, what are we doing, and our purpose. To focus is on one of our technical solutions, dry shot kit. So, Fresinet belongs to Vinci Group, which is the first contracting company in France. We have a worldwide location. Within our group, we have 5 major activities with sol étanche bâchi for foundation, MENA, improvement of soil, Armée, reinforced earth, Fresinet for structures, and NUVIA for nuclear civil work. In the 70s, Fresinet dedicated its activity to offshore structures. In the 90s, nuclear activity in civil works. 90 cable stay, and in repair since 2000, mainly in dams and bridges. Our concept is to scroll from technical concept, design, supply, installation, and monitoring. Every year, we apply for 20 patents. So from now, I will pass the floor to our colleague Kanan, and he will go through our Indian activity mainly.
So I am Subramanian Kannappan, working as a Chief Operating Officer for Fresinet. And in Fresinet, now we have 2 groups in India from Fresinet, Solitange Fresinet. One is Fresinet Menard India. The second one is Rico India. So in Fresinet Menard India, we have currently 105 employees with 8 million euro we are doing a business. And second is Rico India, where we have 200 employees and 12 million. So both these companies are involved in new construction as well as repair and rehabilitation. So our presence is basically, we have a corporate office in New Delhi, and our regional office is in Mumbai, Kolkata, Bangalore and Chennai. So we are geographically present completely in India. And our core activities we started in 2008. First the stadium, SP Mukherjee Stadium in Delhi, where we constructed the roof with a different technology with cables. And this is Kudankulam nuclear reactor, where we installed the post-tensioning, this unbonded system. And we are also into new construction with the hanger bars, and also in dams and barrages we do post-tensioning systems in barrages. and we are also good in stay cable technology. So we have done three stay cable in India. One is Chambal, and the second one is Lakadia stay cable, and third one ongoing is Bardhavan. So these are some activities we are doing in Fresnay, Minad, India, and this is one of the project, ground anchor project we did in Bhutan inside the tunnel. And these are some ground anchor project again in Supreme Court, Delhi, and also High Court, New Delhi, and we are also active in LNG projects in India. So luckily we are working on 3 projects. So these are all small introduction about Fresnay, what we are doing currently in India. So that it's all new build, and we are also doing some one or two projects in repair and rehabilitation projects. So this is about RICO India, where they are doing earthwall structures and also industrial structure and also these rail retaining structures. So about this Fresnay portfolio,